Okay, so I'm going to be speaking about our move in the development environment from Chef to Docker. As a side note, we haven't abandoned Chef. We are still heavy Chef users in production. But for the development environment, we were looking for something which is more lightweight, which is why we moved to Docker almost completely. So I'm going to go with you through the phases that we went through, because most of this stuff is new. Just by a quick raise of hands, how many people are currently using Docker? Okay, how many people are currently using Docker in production? Okay. All right, so yeah, let's start. Some things I will say, maybe you may watch my presentation in 2 months and they will be obsolete. This is the speed of how things are evolving in this space, so just bear in mind. So just a quick who am I? I'm the CTO of JFrog, and JFrog is a company, it's a startup company with branches in California, France, and Israel. And we are developing 2 main products. One is Artifactory, which is a repository for hosting binaries. And the other one is bintray, which is going to be the context of this presentation. Bintray is bintray.com. It's a cloud service. It's hosting a lot of open source and private packages. And the thing that we are going to talk about is the development environment of bintray, which is quite challenging. So bintray itself, it's a distribution as a service cloud platform. If you're using Mac and you're using Homebrew, you are using bintray without knowing. If you're using all the Netflix OSS packages, if you're an Android developer setting up an Android studio, all the dependencies that Android Studio gets are coming from bintray. Vagrant, actually the whole HashiCorp stack is coming from bintray. The Apache Software Foundation, if you download Cassandra today, it comes from bintray. So these are the main open source. There are others that are private. So we have a lot of traction and a lot of traffic in bintray. So the system is quite challenging architecture-wise, but it's also challenging development environment-wise. And in 2013, we actually had a talk here about the development environment of bintray and how we set it up with Chef. And now we're talking about how we moved from Chef to Vagrant in the development environment. Just to give you some idea, these are the main technologies used in bintray. So we have Chef, we have CouchDB, we have Elasticsearch, we have a lot of Redises. It's one of our main technology, Nginxes, and a lot smaller technologies that are not listed here. Another thing which is challenging is the fact that we are very liberal. So developers can pick between a Mac and PC, and they can run Mac OS, they can run Windows, and they can run Linux. So we don't enforce, as long as they can set up the IDE and run the development environment, we're cool with that. And one thing about bintray is that it's made up in a very natural way, it was made up as a set of microservices. So there are many small processes that communicate with each other, many moving parts to take care of, so it's, again, challenging. And in production, it's also a set of multi-data center clusters, because we want to make sure that you can always download, and the downloads are always available. And that makes the separation between the development, going to staging and production a bit challenging. So with Chef, for example, we have completely different Chef recipes in development than in production, because we cannot use the clustered services that are in production. So it's not an easy setup to go with. And this is where things started to get complicated. Okay, so our first idea was, like I mentioned, to use Vagrant and Chef. So just to give you some idea about those tools, it's very lightweight and high-level overview. So Chef, I guess a lot of you know Chef. It's basically an automation platform made out of procedural cookbooks. So and cookbooks are assigned to roles. So you basically run Chef and you configure an existing environment. So this is just that's the definition of a cookbook. And for example, if you want to provision MySQL, then you have some cookbook that installs the service, and so on and so on. And you can do pretty flexible configuration with it. And Vagrant is basically the best definition, I think, is it's a command line for running VMs. So while Chef runs on an existing machine, Vagrant is in charge of configuring a machine, and it's very pluggable. You can configure different types of machine. And then it can also do something which is kind of overlapping with Chef. It can provision the machine. So it can run a bunch of scripts on the machine. And also it has pluggable provisioners. And we were using the Chef Solo provisioner with Vagrant. So our setup was something like that. We have a VM box. So there is actually a missing line here that says that we are using a VirtualBox provider. So we use VirtualBox. We have CentOS installed on the VirtualBox. And then we define a provisioner, which is Chef Solo. And then we tell Chef Solo where the cookbooks are and which cookbooks to run. And from there, so basically, that's what I just said. You check out a Vagrant file, and Vagrant downloads a box for VirtualBox, and then it starts the box, and then Vagrant triggers Chef to provision the box. And Chef plays the recipes to set up everything. Okay, so that was simple, and it was doing the job. Okay. And if you want to see, if you want to visualize it, so we have Vagrant with the VirtualBox provider giving you the machine. So the yellow part is the machine. And then we have the Chef provisioning the actual processes on the machine. So it's simple. But, so first of all, developers, they're kind of messy, so they like to break things. So whenever they break things, they need to rebuild. So what they have to do is they have to replay the recipes. And for that, there are two issues. So the first one is a question of state. So with Chef, if you're familiar with Chef, you probably know that most of the work in the recipes is making sure that if you're not starting from scratch, you have to find at which point you left off. So there is some kind of checkpointing. And then you have to go on from that. It complicates a lot because you have state and you have to make sure to be able to recover and not to do things in, I forgot the word for it, but the fact, idempotent, exactly. So you have to do things idempotently, so you will not ruin the previous state by repeating an action. The other thing is that it takes a lot of time. And by a lot, I mean something that can take by like 15 minutes, sometimes 20 minutes. And for a developer, it's a lot of time. So it's the new slacking excuse. My environment is provisioning, and I can do something else in the meantime. So our solution was simple. We have to pre-build the machine. It's not an UID. So it's used a lot in the VM industry. Netflix are doing it heavily by creating pre-baked AMIs and deploying them to AWS. And then we looked for solutions to basically pre-build our machine. So what we wanted to do is to have Vagrant download the box, and the box is pre-provisioned. We can start it up. Everything is up and running. Problem solved. But we had two problems. Well, actually, one major problem is that whenever we needed to implement a change, it was a manual thing, and it was really, really painful, and we needed to automate it. So here's an idea, automate all things. So we wanted to automate the VM creation. At first, we thought about Chef, which for this goal, it's just running Chef one time, not in a repeatable way. Not in a, it doesn't have to start, it always starts at scratch. So you can run it, it provisions. We didn't like it that much. We're trying to get into a new way. There was a Packer, also by HashiCorp, so it's a VM creation idea. It's a great tool, right? But it was quite new for us, and we decided that we are going to look for something else. And then we looked at Docker. This was roughly about a year ago, and Docker was pretty hot. It still is pretty hot. And we said, okay, we have to look into this technology and see what we can do with it. Yeah, so Docker was everywhere. And the main reason that Docker was appealing to us is because the container ID. So I will give some very brief overview. So basically, in operating system virtualization, there are different ways to do it. What I actually want to show you is that a container is one way which is very lightweight. So this is why it was so appealing for us. So while in traditional VMs you have to fire up full VM, in the container world you just you fire up a process that is capable of a container that is capable of driving a single process, and then you have a lot of resources shared with the kernel, with one kernel, but still you have some resources that are isolated per the container. So the way it works is that you have images that the container starts from. In Docker, it's images, but you have a file system that the container is using, and it has a layered approach. And with Docker, you can basically do a Docker pull, and you get the diff of a Docker image. So you can kind of have everything pre-provisioned, but still you can add to your Docker image, and you can evolve it over time. So it's a very nice advantage. The way it looks is that you have a writable container. You have the kernel, which is shared by all the containers, and so the kernel resources are shared. Then you have a base image. You need to have a base image for getting services such as the file system, libraries, all kind of binaries. So that's for the container itself. So you have like an OS within an OS. And on top of that, you keep adding image differences. So the file system is basically an incremental file system, and Docker is capable of adding new layers and doing it in an incremental differential way. So it's very, very high-level intro to Docker, because the point is how we actually used it with Vagrant and how we replaced what we did with Chef before. And another thing is that Docker very nicely fits the microservices concept, because it has a lot of small containers you can fire up. It can link them up, do port mapping and private networking between them, shared file system, and so on. And one other thing is that we didn't always need all the containers to be up. So sometimes one would develop something that will only require, for example, CouchDB, and it doesn't need Grails, and it doesn't need MongoDB at all, so it can shut down a few containers and be on top of it. But Docker is not enough, and it's not enough because mainly because we are allowing different operating systems, so we need to keep the flexibility, and we need to keep it in an automated way. So if you're on a machine that doesn't support Docker out of the box, and Docker needs a certain level of kernel from the host machine, then we still want to allow you to run Docker. So we still need Vagrant. And Vagrant is basically the one that spins off the Docker containers. It can use pluggable hosts for the Docker containers. And it can even do fully automated things like install Docker for you, run it, and then control it, do Docker pull, run images, destroy containers, link them up, and so on. So it's a very powerful way to manage Docker. So we like that, and we try to tie both technologies together. And we looked at the Vagrant documentation, and then we saw that there is and you can see that it's quite unique in the selection between provisioners and providers. So we have a Docker provider over on the right and Docker provisioner. And it's really confusing. So we didn't really know what to do with this fact that we have a lot of overlap. Yeah, that's kind of how we felt. Okay. So just to tell you a little bit about the difference between provider and provisioner. So when you fire up a Docker machine, the one that is a Vagrant machine, the one that is in charge of configuring and creating the machine is a provider. That's the concept in Vagrant for the one that defines the type of the machine and the one that can configure it. A provisioner basically runs after you already have a machine created, and it's capable of running on the existing machine and provision it like we did with Chef. So the Chef, in the previous case, virtual box was the provider, and Chef was the provisioner. So in the virtual box, for example, there is all kind of port mappings, definitions, all kind of sync folders, and other low-level things like that. And then we have the Chef provision the existing box, existing machine. And when you run a Vagrant destroy, basically it gives you, it kills the box. It takes a machine, throws it on the floor. You have 0 machines, zero provisioning, and 0 box. So our second solution was to use the Docker provisioner. So we kind of were on the fence between provider and provisioner looked a bit easier for us. It looked a bit simpler. It's also not going the full way regarding automation. So when we'll get to provider, I'll explain better what I mean. But it just looked a lot simpler. So the way we had it set up is that we have Vagrant. We still use a provider, a virtual box provider. We set up CentOS, which was our, well, currently in the switch to Ubuntu, but this was our operating system at the time. And then we run Docker provision to start a Docker container on the machines with all the services. So our idea at first was that we will have the services in one container. The way it looks in a Vagrant configuration is that we have the virtual box provider. Of course, the config is a lot longer, but that's the essence of it. And then we have a Docker provisioner that gets a huge, big monolithic image called bintray, which has all the services pre-provisioned on it, pre-installed. And when you do that, it's kind of completely against the Docker way of thinking. But for us, it looked natural, and also because there was an amazing amount of suggestions on Stack Overflow of how to get this kind of setup working. Not only on Stack Overflow, blogs and things like that. How do I create a Docker container that contains multiple services and control them, even though that Docker allows me to control one process? So it was kind of doing procedural programming in object-oriented, or it's not the paradigm shift that we need. So there are solutions like Monit or Supervisor that allow you to do that, but it's really the wrong way. So we said, okay, let's look for something else. It's not the best way to do it. So our third solution was, okay, let's still use provisioners, but instead of having one monolithic container, let's break it up to small containers. It's a pretty simple setup. You have the virtual box provider like before, and then we use different Docker provisioners to fire up the containers, and it's really, really, really simple. So we have the virtual box provider, and then the Docker provisioners, so a Mongo provisioner that we tagged, and a Couch provisioner, and so on. So it's simple. But developers, they break things, and when they do, they have to reprovision the machine. And the thing is that when you do a Vagrant destroy, it completely kills the machine. So it kills, so you get back to a no machine, you get back to you have to fire up a box from the beginning, and you have to get and pull all the images again and again and again. It can work nice. It can work nicely, but the issue is that a lot of our developers are working crazy hours remotely over the VPN. And even though in the office we use Artifactory so Artifactory that is made by us is also a Docker repo. So we have a private Docker registry in-house. It's very fast when you're in the office, but when you have to pull images over the VPN, it's a disaster. And you have to wait for a lot of time to get something like a few hundred megs at the minimum to get started with. So we looked for another solution. And then we came, what I'm going to show you now in the next two solutions is probably the most common solution today to running Vagrant and Docker. So the thing is that instead of using provisioners, we are going to use providers. And then we are going to use Vagrant for managing those providers. So I'll explain, so you don't have to get everything from this slide. So basically, Vagrant is very smart. When you use Docker providers, it's smart enough to let the provider run a Docker container on the machine automatically, install it and run it. And it's also smart enough that if you're on a host like a Mac or Windows, it's smart enough to provide you with a VM, with a virtual box. Out of the box, it comes with VirtualBox, and a VM that is capable of running Docker inside. So for a developer that is on Mac or Windows, which is the majority of our developers, by the way, Mac, not Windows. So for them, it's going to be a fully automated process. They are capable of running a Vagrant app, and then they will have a Docker app. And the same for if somebody is on Linux, and we have developers on Linux, they will be able to use their own Linux machine to run Docker on it. They will not need any abstraction or overhead. And on Mac and Windows, there is this boot to Docker, which is using a dedicated tiny core Linux operating system. It's around 27 megs of RAM, and it fires up in around 5 seconds. So it's very, very lightweight, and it's very, very cool. And it gives you a VM that fires up very, very quickly, allows you to run Docker on any host. So the setup is something like that. We have Vagrant that spins up, optionally, if you're on Mac or Windows, it spins up a boot to Docker host. Otherwise, it's using your native operating system host. And then it starts running containers using the providers. The Docker providers, Vagrant providers, sorry. This is what it looks like. So first, there is no box anymore, okay? Vagrant is smart enough to give you the box if you need a box, or use your machine if your machine is good for running Docker. The other thing is that we are using providers, so basically, instead of running provisioners, we're using Docker providers. And in those providers, there is a set of instructions here to pull the image and to run it and everything. So it's very nice. And the thing is actually, with this setup, you have full automation. Okay, so there is always a but. Okay, so. And the problem is right here. The problem is that those environments between different developers, they are not the same. So we were kind of uneasy about developers running into issues by running a completely different operating system. And we have a lot of processes that are low-level processes and that require a lot of libraries from the operating system. So we felt bad about having different operating systems, running them even in development. But the good thing is there is a solution for that. By the way, another thing that we were kind of not feeling good about is the fact that we are polluting the developer machine of the one that's on Linux with the development environment. So we don't have a clean environment for running Docker. So it's mixed between his own experiments with Docker and his own version of Docker and what's on the other ones that are running boot to Docker. So, of course, we will have to do something different now. And the good news is that it's easily solvable because what we can do is we can give up boot to Docker, and we can use an external box provider. Basically, we're going back to the idea that instead of using the full automation of boot to Docker on Mac and Windows, we can fire up another Vagrant box. Okay? So it's easier to explain like here. So basically, what we are doing is instead of running boot to Docker, we are finding a common ground. We are running the CentOS as an external Vagrant box that those Docker providers are going to use. And Docker is smart. When you provision another box to run and it runs the providers, it knows to actually join an existing Docker process and not start a new VM. And the way that it works, that it looks like in the configuration, is that basically we have a Vagrant file pointing, a variable pointing at an external Vagrant file. And we have, in the Docker providers, we say this meta instruction, vagrant file equals this Vagrant file. So what will happen here is this external Vagrant file will be used to fire up CentOS 6. So Docker images will run on those CentOS 6. And every provider will keep using this CentOS 6 as the runtime. And this is what the external Vagrant file looks like. So you can see that it has a provision. So here it gets a bit messy, but it's not too bad. So we have a Docker provisioning here, meaning this will install Docker automatically for us on CentOS. It's like we had in the very first example. We can actually control the version of Docker that gets installed. It's not shown here, but we can be in charge. We can make sure that when people run it in different times, they will get different versions of Docker, the same version of Docker, that it's not always the latest version. And we are using, again, VirtualBox as a provider. And this is just an example of how we download the CentOS box. So we download it from our local Artifactory server. And that was really nice because it gave us a unified environment. So this is, by the way, what I showed you here is if you start looking for blogs and start searching the web, that's the most common way to do it. It's very easy. Another thing is that it gives you, from Vagrant, it gives you control over the Docker images. So you can do Vagrant destroy, and it keeps it doesn't destroy the caches, it doesn't destroy the Docker caches. So it's really elegant. So it will just destroy a provider. You need to specify the machine name of the provider to destroy, and it's going to only kill that. So it's kind of a very flexible setup. Yeah, and that's the most common way to do it. So we did like it, but there are some buts here as well. Okay. So first thing, there are kind of minor issues, but they started to get in the way. So first thing is that you have to make sure that you don't run. You have to remember to put no parallel or create your own script. It's not a biggie, but otherwise the providers are trying to fire up the same machine again, and you have to make sure that they run in a sequential way. So SSHing to the machine and destroying it is a bit untrivial. To do SSH, which developers were used to, you have to go to this. You have to go to where the other Vagrant file resides to do the SSH from there. And if you want to destroy the full machine, which sometimes you do because things get messy, and then you have to. There is a flag in Vagrant to identify in the global environment to identify the ID of this specific Vagrant VM and to kill it. Again, it's not something very complicated. You can get used to it, but you have to understand that this is a development environment. And the issue that DevOps were facing is that once we started to move to this setup, they started to get too busy with developers coming to them asking for help. So developers, they just want to get the job done, and not all of them want to start learning Docker, and not all of them want to start learning working differently with Vagrant. They just expect their Vagrant app and destroy to work, and they expect that when they do destroy, they don't run into issues like having to wait hours, because before they were used to have Chef. I mean, the base VM was there in a minute, and then it was natural for them. They can see a progress that Chef is building something, so it was kind of okay for them. Another thing is that we had some issues also when we checked out and switched to different branches. Sometimes, and the DevOps couldn't find out exactly why. Sometimes the Vagrant caches would get completely corrupt, and file handles would get lost. So some services were getting killed. So this was kind of some of the issues we ran into. And some developers, they were kind of not willing to go to this new paradigm. Other more advanced developers, they were feeling very good with Docker, and they started pushing their containers and updating them. And working with Vagrant didn't seem like they didn't like this abstraction at all, to do everything the Vagrant way and work with Docker in the Vagrant DSLs and in the Vagrant syntax. So it was one other thing. Another thing is that the official boot to Docker image, we still wanted to use boot to Docker because it's very lightweight. And then we couldn't find a good boot to Docker images. We had some issues with mounting files, and the boot to Docker itself was not up to date with the latest Docker releases. And we said, okay, we want to use this fork of boot to Docker, which I will show you in a minute what we've done. So we were looking a way to get more lightweight and also allow developers more control and to simplify things a little bit. So allow the advanced developer to do their changes, while allowing the ones that are less advanced and work on more stable components to stay to have something very simple like Vagrant up and destroy working. So we moved to another solution. So that's just another idea. Okay. So here comes what we are actually using today. So I mentioned this. So what the idea was is to still use Vagrant and Docker, but take full control of the box. So we wanted to have boot to Docker of our own that is used between all the OSs. So instead of CentOS as an abstraction, we still wanted to use boot to Docker. And we wanted to have the base images as part of the box. So when you are doing Vagrant destroy, you still and you get back the image, so that you have the image. So Vagrant keeps the image in a cache on the file system, on your local machine cache. So we wanted to be in a situation when we fire up Vagrant, we are in a working situation. So the box is there and everything can start working. You may have to do some updates, but you remember that updates in Docker are incremental. So those updates are not that horrible to begin with. You don't have to go through the whole ancestry and get your images. And the other thing is we wanted to use the fork of boot to Docker. First, it's very well maintained. So it's on top of the latest versions. It has nice additions such as the Docker enter command, which allows you to get like a pseudo TTI you can kind of get a console into the machine. You can do it today, by the way, with Docker exec, but at the time it was not there, and this was a nice way to SSH to the machine, which is sometimes important. And here we looked at this. This is available on GitHub, and to build, so basically it's building a virtual box VM. Okay, so it's building a virtual box with the latest Docker, with other kind of enhancement, and the way it's doing it, it's using Packer. So mainly because it's a fork of a project by HashiCorp. So this fork is using Packer, and Packer is allows you to build machine images. So in this case, we're building a VirtualBox image. The way it looks like is something like that. So we have a build time. So those are completely different phases, right? So when Packer is in the picture, it's a build phase. So it's building a boot to Docker image with base images already provisioned on it. So we have, say, the base Mongo, base Couch, base Elastic. And then we have, it's very similar to our step 2. So we provision a VM image, a box that is capable of being run in VirtualBox. And then when we run it, we run provisioners again, Docker provisioners. And we are basically firing up Docker. So we provision Docker, and we're firing up those containers in provisioning time. This is what the configuration looks like. So what you see at the top is the way to tell Vagrant automatically to pull the box. And the box is hosted on our local server, again in Artifactory. And then we start up the box with VirtualBox. And then we have the normal step of provisioners. Actually, there's a line missing here. We are doing a pull just to make sure that you're on the latest version every time you run the image. Not all our images have a pull. For example, Couch rarely changes, so we don't. For some reason, there is no pull there. But Mongo and other images, Elasticsearch for sure, we are doing a pull before we run the container. So that's very simple. Everything is there. The way it looks like in Packer is that we have, so it's nice that the concepts kind of align between Vagrant and Packer. So you can see that as part of provisioning the machine, we are doing a Docker pull from our internal Docker repo, and that gets installed on the VirtualBox box when it's being built. So we have a build phase that has to be repeated from time to time that has all the boxes on it. And it really speeded things a lot, especially I think the CentOS box was approaching 1 gig, and now the one with boot to Docker and all the images with all the ancestry that was in the way is something like less than 400 meg, so 400 gig. So it was one tera. Sorry, 1 gig and 400 mega. So multiplied by 1024. Okay, so it was, we liked it. We really liked it. And the one that liked it a lot were the DevOps, mainly because they are lazy and they didn't like people coming back to their desk asking them all kind of Docker questions, especially not developers that are not advanced Docker developers. So it's kind of, instead of being like a flourishing conversation, it became problem solving. So they were happy. We still have quite a few challenges with it, although we're happy with the solution. So there are kind of workflow issues mainly. So updating the base box, how do we make sure that we have to manage versioning for our box? Not a big deal, we're just using timestamping. But there is this decision on when the box has drifted enough from the base images so that the pools are getting too long to execute. And that's a purely manual decision. Okay, so while the building of the image is fully automated, we don't build it in an incremental way. There is a Jenkins job that will kick off the build and everything, but it's not running based on commits or anything like that. But it's kind of a, I don't know, a fuzzy decision of the DevOps on when, and mainly triggered by developer feedback on when images should be rebuilt. Mainly it's done when we are upgrading to new versions of Mongo or upgrading, we're doing a considerable infrastructure change that requires starting from scratch. There is also the fact that developers, if they want to, so they have a machine they can log into, like they have a virtual machine of their own. There is Docker running on the machine, so they have to know Docker if they want to do advanced Docker stuff. Most of the developers, they are very happy about it, but some are still struggling if they want to shut down a container. So there are still cases where developers would come to DevOps to ask for help. So it's the best solution we reached so far. We went through a lot of them. It's not, like I said, it's not the common solution that you will find out there on the web. But for us, it works, and that's what matters. Just to recap, so the way it works, just to give you back an idea. So Packer is building a custom boot to Docker image and pull the base images to it, so they are pre-installed. Then Vagrant downloads the box from Artifactory, and then it runs the boot to Docker virtual host, the custom boot to Docker virtual host, virtual box, not host. And it pulls for the latest version of the images and starts the container. And when you do a destroy, it keeps the base image of the containers. So that's the whole flow in 5 bullets. It's really that simple. It was I ran through it, I think, very fast, but it was a real journey for us until we found out what the best way for us is to do it. And like I said in the beginning, Vagrant is changing rapidly, Docker is changing rapidly. There is a new ecosystem flourishing around Docker automation between containers, mainly for production, but I assume the same thing will happen in the development environment. So it's something that maybe have to be, we may have to reconcile it in a couple of months or in a year or I don't know when, but currently this works for us and we are very happy. So I was, I think, going very fast with my talk, and we'll have plenty of time for questions if you want, because I'm done. Thank you very much.